Pick out the key information. What do we need to know that's in these words? We need measurement, x, and we definitely need the word degrees.
20.
Thanks for spoiling the fun there. Now, the examples I do today, there is not one correct way to do it. I'm going to show you one way, maybe two ways, but if you've got a different way that works for you and you get the same answer, great. It doesn't mean that my way is the only way to do it. So I'm going to take suggestions on this one. What do you want to do first? What, we want to convert what now to what? Why do we want to do that?
Because we're working with degrees.
Absolutely. That's a great first strategy because the question says degree. So let's get the radian out of there and convert it to degrees. How? Ooh. Do you think this would be a calc question or a non-calc question? This would be a non-calc. So again, ignore the 0. Look at 18 divided by 3, then plunk that 0 back on. I heard like a really quiet little 60. Make sure you've got your degree symbol on there, otherwise it's 60 rads, which is completely different. Okay, great first step. Now what? Why? Why? This is one of my favorite questions because you're all like, I don't know, because somebody told us. Well, do you accept something everybody tells you? Is it always true? Okay, so let's pause. So it's up to you. I'm just going to write down the math rule, and then we're going to put it in a highlighter box so it's in your notes. If you already know it, don't worry about it. But the property we're saying is if, not if, for any triangle, which I can't even spell triangle, triangle, ABC. I did, and then I took that away. For triangle ABC, angle A plus angle B plus angle C equals. See, now the visual people will picture the little corners of the triangle, and the tactile people got to play. Sorry, auditory. But I'll say it again for you. For triangle ABC, angle A plus angle B plus angle C always equals 180. So that means that 100 degrees plus 60 degrees plus x has to equal 180. 100 plus 60 is, subtracted to the other side, 180 minus 160 is 20 what? 20 degrees. Bless you. There's application number 1, taking what you already know about triangles, just throwing radian measure into it. Example number 2, read it. Bless you. Keywords. 4 o'clock, definitely important. Rads, definitely important. Here's how you know if you have all the keywords. Close your eyes, and if I can see the whites of your eyes, they're not closed. And I'm going to read you back what we highlighted, and you tell me if we have enough information. Rads, 4 o'clock. Okay, so if you don't think we have enough information, open your eyes, go back and find what's going to give us more. If we have it all, great. Yeah, I probably would add between the hands. If you understood with rads and 4 o'clock, that's fine. I'm going to show you one way to do this question. It's only one way. There are a bajillion more ways to do it. If your brain has a different way, that's a-okay. I'm just showing you a way. This is how my brain works. I start with a picture because I'm visual. And I put the hands on my clock. We know one's at the 12 and one's at the 4. Now for right brain people, they usually look at this and go, but wait, there's 2 angles when you have hands of a clock. How are there 2 angles? There's one in between them this way, but there's also one on the other side. So you need to know that the question is asking for the smaller angle if it doesn't state otherwise. When we're dealing with clock questions, it's looking for the smaller angle unless it says otherwise. So not the one on the other sides of the hands. How many sections are there on a clock? There are 12. So what my brain does is says, okay, we need 4 out of the 12 sections of a clock. And that's going to be a fraction of the total clock. What's the measure of a total clock? 360, except I know the question needs rads because we highlighted that. So what's the equivalent to 360 in rads? Is 2 pi. So all I want to know is what's the section of the full clock that's the equivalent to 7 on 12. How do we multiply fractions? I heard cross multiply, I heard common denominator. No. The only time you cross multiply is when you have two fractions and there's an equal sign in the middle. That's cross multiply. The only time you common denominator is if you're adding or subtracting. Top times top, bottom times bottom. Okay, that's how you multiply fractions. 4 times 2 pi. 12 times imaginary 1. 12. Can we reduce the fraction? What can we divide them both by? 4. Top becomes? Bottom becomes 3. I'm going to show you a completely different way to do the question. If you're like, nope, I got this, I don't want another way, then don't write it down, just sit and watch. Full clock has how many sections? Full radians around. Full radians around. 2 pi. So what I'm going to do is divide the full amount of radians into 12 sections. So how many radians are in each section of the clock? Pi on 6. I just reduced that fraction. How many sections do we want at 4 o'clock? So if each 5-minute section is pi on 6, how many 5-minute sections are there between the 12, and the 4? So we want 4 of them. How do I multiply fractions? Top times top, bottom times bottom. Pi times 4. 6 times imaginary 1. Reduce the fraction. 2 pi on 3. Different way to look at the exact same question got us the same answer in the end. I'm going to show you a third way to do it. If you're like, no, thank you, then just stop listening to me for about 3 minutes. If your brain works better in degrees, then work with degrees. What's a full circle in degrees? There are still 12 sections of the clock, whether we're dealing with radians or we're dealing with degrees. So how many degrees is in each section? 30. Each 5-minute section is 30 degrees. Between the 12 and the 4, how many sections do we want? We want 4 of them. So if each section is 30 degrees and we want 4 of them, how many degrees is there between the 12 and the 4? Now I need to change that into radians, so go back to what we did yesterday. How do we change degrees into radians? 120 over 180 equals r over pi. How do we get rid of a division by pi? What's the opposite of dividing by pi? And we tuck it in the back. And then reduce the fraction. What can I do with the zeros first? Get rid of them. Why? Dividing by 10. Now I'm looking for the largest number that divides into 12 and divides into 18. 6, how many times does 6 go into 12? How many times does it go into 18? There you go. 3 completely different ways to do the question. If you get one of them, great. If you get all of them, fantastic. If you have a completely different way and it gives you the right answer, I'm fine with that. Whew, questions so far? Does it annoy you yet that I'm showing you different ways? Yeah, it's going to annoy left brains. Sorry. Okay, number 3. Here's the longest word problem that we've seen so far. And so for longer word problems, I have a 2-step approach, and I'm going to say this to you all semester. Step number 1, don't do it yet. You're going to do what I call read to read. Read to read is don't start thinking about the math behind this. Don't overanalyze it. Just read it like this was a sentence in a really boring book. Then we're going to do read to understand. And read to understand is where we're going to pick out those key words and start looking at the math behind it. If you try to do both at once, your brain is trying to understand what the English words mean and what the math is, and it gets confused. So read to read, just read it like it's a sentence in a book. Go ahead. Read to read. You're like, I'm putting this book down. Tell me what it's about after you've read to read. A clock. And that's maybe all you got the first time through, and that's fine. What your brain is doing is now picturing a clock, and it's tapping into everything you know about a clock without you thinking about it. Now let's read to understand, because you've got the idea of the context in your head. Let's pick out the key words. The first sentence, what are the key words? What's the most important stuff we need to know? 9:10. Do we need to know it's the hands of a clock? Maybe you do, maybe you don't. That's completely up to you. When I look at a time, know it's talking about a clock, but if you want hands of clock, you highlight that. The second sentence, which is the long one, what do we need to know? Okay, something with 7 pi on 3 rads. Minute hand rotates. I like that because it's telling you what and what it is and what it's doing. Angle clockwise. Okay, the last part, usually we need the verb, what it's telling you to do. Is it telling you to solve, to simplify, to find, to describe? What's it asking you to do? Find the new time. If you approach word problems like this, you're going to find out word problems are going to become a lot easier. You're also going to find is most of the words are relevant to mathematicians. I don't care really about all the things I haven't highlighted. All I care about is the numbers and what I need to do. Again, here's how you know if you have all the key information. Everybody close their eyes. I'm going to read you what we've highlighted. Some people did hands of a clock, 9:10, minute hand rotates, angle of 7 pi on 3 rads, clockwise. Find new time. Is there anything else you need to know from what's printed there? No. That's how I approach word problems, is how I'm going to do them all semester. I always say read to read, which is just reading, not thinking. It's just putting the context in your head. Read to understand is where we pick out the key things. And sometimes I'm going to do that with you. Sometimes I'm going to have you do that with a friend. Sometimes you're going to be all alone and trying to do that. Okay? Again, I'm going to show you one way to do it. It's one way. If you have a different way, that's A-okay. What do you think I'm going to start with first? I'm going to start with a picture because it's how my brain works. It works in pictures. If yours does not, then don't worry about it. So one hand is at the, and one hand is at the? 10. Somebody always says 10. It's at the 2. Why is it at the 2? Because that's 10 minutes. Okay. We know that this hand went around, clockwise, that's clockwise, right? Clockwise direction. We know something happened here, and we know that the clock hands changed. Here's the numbers we're given, and the numbers are always the most important. What I'm going to do for this one is I'm going to work in degrees because your brain is still working and learning rad. So what I'm going to do first is convert it just to give you a frame of reference. I'm going to put in my 180, divide by 3. Do you think this would be calculator or non-calc? Yeah, this is something you can probably handle non-calc. So 18 divided by 3, 6. And then 7 times 6. Oh, it saddens me that it took that long. 42. And what do I do with this 0 that was hanging around? I just tag them onto the end. Okay, so it's 420 degrees. Now, when you see that degrees, you should pick up on the fact that was more than one circle. Why? Because one circle is 360. So what does that mean about our hour hand? What does it mean about our hour hand? We know that, not 12 hours, but we know that it moved at least one spot, so one full revolution. So all I'm going to do is I'm just going to split this for now. I'm going to say, well, 360 of it would have been 1 hour. So I'm just using some logic skills here. How much do I have left? So if I use 360 doing that full hour, how much of my 420 do I still need to talk about? 60. Well, if you use the logic from the last question, we already calculated how many degrees was in each section of a clock. We said, and I'm going to put that in red because it's coming from the last question, 5 minutes or one section is 30 degrees. Okay, and we did that just by the simple calculation in the last one. So tell me, what do you know about 60 degrees? That had to have been 10 minutes. I'm just going to back up there and repeat the logic. All I did was to convert to degrees. Would I, as a mathematician, convert to degrees? No. I would leave it in rads because I know how to work with rads. When you're just beginning, if you're more comfortable in degrees, flip it to degrees. So I went to degrees and I said, oh, well, 420, I know that's more than a circle. So I now just split it into a full revolution, which is 360, and the leftover. I know a full revolution is 1 extra hour because it means the minute hand has gone all the way around. We use the logic from the last question that every section on the clock is 30 degrees. That came from 360 divided by 12. So that means 2 sections has to be 60, and that's 10 minutes. So if the time was 9:10, what is it now? Well, my extra hour is going to make it 10, and the minutes of 10 is going to go to 20. Final answer is 10:20. Lefties, we're boxers. We just like to box answers. I just do it so it stands out at the end. That's one way to do this question. I'm actually only going to show you one way for this one for sake of time. If you've got a different way that it works in your head and you can get the same answer and you can show me the logic, there's nothing wrong with that. How are we doing so far? No, unfortunately not. Because it's the second Tuesday because teacher started last Tuesday. I know. Okay, we're going to look at a new application of angles which is called arc length. This is brand new to you. Little definitions about circles. When circles turn, the circumference rolls along the ground and the angle of revolution increases. Nothing surprising there. We know what happens as a tire rotates. So what's actually touching the ground is the circumference of the circle. The length of the circumference that touches the ground, is called the arc length. So all of the examples here we'll have to do generally with wheels that are spinning. Could be tires, could be something else, but generally circles that are spinning. We can calculate the arc length using the following formula. S equals theta times r. S equals theta times r. What is S? Well, that's the abbreviation for arc length. Why an S? I don't know. Some dead guy picked it. Some really old textbooks, you'll see L for arc length, but then we did away with that because sometimes L is like length of width of a rectangle. So somebody picked S. I don't know why.
Must be from a foreign language or something.
I don't know, something. What is theta? It's the angle of revolution. How did you know right away that was an angle? Because theta is always an angle. What do you think R represents? Here's a hint. It's a circle.
Radius.
R equals the radius. So what this formula allows us to do, if we know the radius of the circle that's spinning and we know the angle of rotation, we can calculate how long it traveled. Or vice versa. If we know how long it traveled and we know the angle it turned, we can calculate the radius. Or vice versa. If we know the angle that it traveled and its radius, we can calculate the angle of rotation. So this can be used to find any S, theta, or R. Notes. Notes are always bold and capitalized when they're really, really, really important. And then I write them in red pen because they're really, really, really important. So you know the day before a test when you're supposed to be studying but you're really texting your friends? One of the things you should be doing is reading through your notes and look at the things that say note or the things that we've starred or the things that we've boxed because it means it's really important. This formula only works and then I underline for emphasis, only works when theta is in rads. And that's why you've never seen it before, because you didn't know rads before. This will not work in degrees. You will not get the right answer. Theta has to be in radian measure for this formula to work. Okay, so what kind of questions might they ask? Well, let's start with example 4, which is the easiest. If a tire has a radius of 0.5 and turned 3 rads, how far did it travel? There was your read to read. Let's read to understand. What are the key words? Radius of 0.5. Now to a mathematician, I don't care if it's a tire, a wheel, a donut, anything that's circular. The minute I see radius, I know it's a circle. So to a mathematician, it's irrelevant. It's scientists that care what it is. We don't care. So radius of 0.5. What else do I need to know? Turn 3 rads. What do I want to find? How far? Travel. Close your eyes. I'm going to read you the highlighted words. Tell me if we have enough information. Radius of 0.5 meters. Turn 3 rads. How far? Travel. I think we're good. Now, I'm going to talk all semester about exam panic, and I know that you have been there at some point in your life. It is like hour 2 of the exam. It is hot and sweaty because the heat is on and it's January, and it's a little stinky because everyone's a little nervous. And you look at the question and you freeze. And you're like, I have no idea how to do this question. I don't have any idea. Everything I've been learned all semester is gone from my head. Anyone ever been in exam panic? I'm going to talk a lot about exam panic. I'm going to tell you the things you're going to do in exam panic, so hopefully if it happens, then you can fix it. In exam panic, what's going to happen, you're going to be like, I don't know anything that looks like this. So you need to be able to link it to something we've done. How do you know this is an arc length question? Arc length is always about what? Always about rads, but other things are about rads. What's the key to arc? Something that's turning, and more specifically, a circle that is turning. So up on the title where it says arc length, you might want to put a note for yourself if you're a wordy person, turning circles, circles that turn, something like that, to remind yourself it's always going to be arc length when you're dealing with a turning circle. Do you need to know this formula, or is it on your formula sheet? And you have a really fast way of knowing because you put your formula sheet in the plastic sleeve, so flip to the plastic sleeve because it sticks out and you know where it is, and see if you can find the formula. First one at the top. They're actually pretty much in order that we're going to learn them. So we're going to go down the first column, then down the second column, which is kind of handy. So it's on there. So all you need to know is really how to get the formula off the formula sheet. The note is not there, though. And what do you need to remember about this formula? Theta has to be in rads or it doesn't work. I'm going to show you a little trick to do word problems if you're left brain, but if you're right brain, still pay attention because it might work for you. I do what I call inventory, and what I do is I go through the question, I look at the numbers, and I just put them off to the side for a second. So we have 0.5 meters, and we had 3 rads. And then what I do is I think about the formula and I associate a letter. So which of the letters would be 0.5? Well, it says right in the question radius, so that has to be R. What is 3 rads? Well, rads is an indication it has to be an angle. Therefore, what's the only thing left? What are we looking for? Has to be S. That's a very left brain thing because we like things in steps. If that doesn't work for you, don't do it. So you grab your formula sheet, you get the formula off it, S equals theta R. Now we're just going to sub in. S I don't know. Theta is 3. R is 0.5. This is just a straight up multiplication, non-calc, 3 times 0.5. 1.5. 1.5 what? What do we measure arc length in? It is in meters because it's a distance traveled. So this is 1.5 meters. Really, it's that easy? Yes, it's really that easy.
Is the radius of the 3 meters?
Sorry, the radius?
If your radius is in kilometers, will the answer be in kilometers?
Yes, so it follows from the radius because they're both distances. Good question. Number 5, read to read. It's 2 whole sentences. Again, don't overthink it on the read to read. Don't start to think about the math. Just put the context in your head. What is this about? A unicycle. And that might be all you get on the first time, and that's fine because what is your brain now doing? Your brain now is thinking about everything it knows about unicycles without you telling it to. And so it's already putting that pre-information in your head, and it's thinking about, okay, what does it look like? How does it move? Now let's read to understand. What do we need to know in the very first sentence? Diameter of 70 centimeters. The second sentence. Rolls forward. I could go either or, because the distance in terms of math doesn't matter if it's backwards or forwards. If your brain wants forward, then highlight forward. The next sentence. What angle in rads wheel turn? And maybe you just need turn, and that's fine. Maybe you don't need those at all. And the last question? How many revolutions? Okay. Again, for the left brain people, I like to do that little inventory off the side. If it doesn't work for you, don't worry about it. So we know the diameter is 70. But I'm going to think ahead, and I know I don't need the diameter. It's really hiding what information. It's like a little secret way to give you the radius. What do we know the radius is if the diameter is 70? 35. So then sometimes I cross that out because it tells my brain I don't need it. So it just matters the way your brain works. Rolls 15 meters. So I know something is 15 meters. Which one of my variables has to do with rolling? S, because that's the movement piece, is the distance it traveled. What angle tells me I don't have the angle. And then it needs something about the revolutions. We haven't talked about that yet. I'm a little scared by that. We'll leave it for now. Okay, where do you want to start? You slap down that formula because that's a half mark even if you do nothing else. If you can get that formula down and then your brain cuts out, you're going to get a half mark for that. What can I sub in? What do we know? Okay, 15 is S. Theta don't know. Radius is 35. We usually put units at the end, but you can put them through the equation. Oh, 1 is centimeters, 1 is thank you, I totally didn't even notice that. Bah! Grabbing the red pen. Absolutely, we need to change. Do you want to change into centimeters or into meters? Did the question specifically ask for either one in an answer? No, so you want to go meters or centimeters? Okay, so we got to change this one to meters. .35 meters, that sounds confirmed. How many centimeters in a meter? Well, if you speak French, it's easy because cent at the beginning of centimeter means what? 100, so it's telling you it's 100 in there. So let's put the decimal point in there. Whew, that was a close one, thank you. Don't let theta scare you. Theta is just a variable. If your brain needs to put x in there and you need to see it written like this, then do that, because you've solved these a bajillion times. There is no difference between these two equations. What does your brain want to do here? Divide by 0.35. So exactly the same thing here. We're going to divide each side by 0.35. Sorry, 42.9, that's rounded off. 42.9, looking for confirmation. Units. Yeah, rads, and what's the unit for rads? There isn't one, which is ridiculous. So just in brackets, I'm going to put rads just so you remember later that we did talk about units, that we didn't put any because it's radian measurement. Okay, that wasn't so bad. Oh, shoot, we got that revolution piece in there. Crap. Okay, what do you want to do? Well, how much is 1 revolution? 2 pi. And then 2 revolutions would be 4 pi. And 3 revolutions would be 6 pi. Hello, do you need me or my machine?
No, I just want to apologize for
Oh, no, I kicked you off because I didn't even notice. I just logged in and I'm like, oh, look, she's working. It's all good.
But hopefully everything's working.
Yeah. So let's just repeat that. 1 revolution we said was 2 pi. That means 2 revolutions would be, and 3 revolutions would be, and 4 would be. So how many is 42.9? So revolutions equals whatever the angle is divided by 2 pi. Go ahead and tell me how many times this wheel on the unicycle revolved.
6.8.
Offer of 6.8. Confirmed. Units. So is revolutions a meter? Revolution is accounting, so there's no units. It's like how many apples? There's 5 apples. How many revolutions? 6.8 revolutions. There's our final answers. This was a 3-mark exam question 4 years ago. The first part was worth 2, so getting the 42.9, and there was 1 mark for the revolutions of 6.8. Last one for today, number 6, read to read. Don't overthink it. Just put the context in your head.